Alrighty, so for this week's lesson, I'm going to be talking about multiplying and dividing exponents. So at this point, students should have an idea of how to add, subtract exponents, and the parts of exponents. So getting into my lesson, we're going to start off with multiplying exponents. If I want to multiply my exponents, let's take the example x to the third times x to the fifth. Now, when we look at this, we might say, well, how are we going to do this? And to start off, I'm going to kind of unfold all of it and unwrap all of it. And then after a few examples, you should be able to see a pattern that's going to make it a lot easier so you don't have to unravel everything. But just to start off, I'm going to talk about unraveling it. So let's unravel this. So if we were to do x to the third, if we were to see that unfolded, that would look like x times x times x, right? And then if we were to see x to the fifth, we would see it come out as x times x times x times x times x. So we'd see x times itself 5 times. So if we take this part, we see x to the third. And if we take this part, we see x to the fifth, right? And so when we multiply, we want to make sure we have the same base. In this case, we do have the same base. Our base here is x and x. And once we realize that we have the same base, we're just going to add our exponents across. So if we see x to the third times x to the fifth, we could see it as x to the third plus 5. And then that is going to give us the answer of x to the eighth. And we can see that because, like we said, x to the third is just x times x times x. So x times itself 3 times. So if we were to count all of our x's here, our x to the third and our x to the fifth, we would see 1, 2, 3, 4, 5, 6, 7, 8 x's. So that tells us that it would be x to the fifth. Now, if we look at another example, let's look at x to the third times y to the fifth. Now, if we were to unfold this, we would see x times x times x 3 times. So this would be our x to the third. And then we would see y times y times y times y times y. And this would be our x to the fifth, or y to the fifth, my bad. Whoops. All right. Now, like we said, in order to multiply these, we need to have the same base. So if we look at our bases here, we have our one base of x and our one base of y. Now, can someone tell me, are these two the same bases? Is x and y the same? No? Yes, that's correct. So in this case, no, we don't have the same base. So since our exponents don't have the same base, we can't multiply these. So now I'm going to give you guys 2 examples to work on your own. So I want you guys to try, if we have 5 to the 7th, we multiply that by 5 to the third, what would we see? So I'll let you guys figure that one out. And then while you guys are working on that, you guys can also work on this one. So we have 2k to the 13th power times 3 to the times k to the 15th. And then I'm going to let you guys solve that one out. So because I am on a 10-minute time crunch, I'm just going to go through these real quick. But in a normal classroom, I would give my students about 3 to 5 minutes to probably solve these two, or if the class finishes earlier, go over it sooner. But I'm going to go over this one for now. So if we were to look at 2k to the 13th times 3k to the 15th, how would we multiply this? So when we see 2k to the 13th, we know that we're really saying 2 times k to the 13th. And so the same can be said here. If we multiply this by 3k, we see 3 times k to the 15th. And then we know that multiplication is commutative, so we could do it in any order, it doesn't matter. So if we want to move our terms around so that maybe we could see this a little bit easier, we have our constants, 2 times 3, and then we could do our exponents and our variables. So we see k to the 13th times k to the 15th. Now, if we were to look at this, how would we solve this? Can someone tell me? Yes. All right. So we're going to take our coefficients here, and we're going to multiply them together. So we would see 6. And then we want to multiply our k to the 13th times k to the 15th. So do we have the same base here? The answer should be yes. We have the same base. We see k and k. So if we were to multiply these together, we would add our exponents. So we can see 6 times k to the 13th plus 15. And then if we were to simplify that out, we can see 6k. And then when we add 13 and 15 together, we will see to the 28th power. So this is how we are going to multiply our exponents. And now I'm going to go over real quick. I have a little time crunch, but I'm going to go over division real quick. I know I might be moving a little quick, but I'm trying to get through both of these right now, and obviously I only have 10 minutes. So if we move on to division, so when we are dividing, we looked at multiplication. When we multiplied, what did we do to our exponents? Yes, we added them. So if we're dividing our exponents, what do we think we are going to do with our exponents? Correct. We are going to subtract them. So if I had a to the 7th and I divided that by a to the 2nd, we could also see our division, which might be a little bit easier, as a to the 7th over a to the 2nd. And I just want to unravel this again. So if we're going to unravel this and kind of spread it all out, what would we see in the numerator? We would see a times a times a times a times a times a times a, all over a times a. So now that we have our division set up, we can also just see that we can cancel out our a here and our a here. And we have another a that we can cancel out. So we do a and cross out that a. And now all we have left is our numerator. And what do we see in our numerator? How many a's? Correct. The answer should be 5. So if we count, we see 1, 2, 3, 4, 5 a's. So that means our final answer here is going to be a to the 5th. Now, can anyone tell me something that maybe they noticed between a to the 7th and a to the 2nd and our final answer of a to the 5th? Correct. So the answer should be that we see that when we take our 7 and our 2, we can actually subtract them when we're dividing. And so if we did our a to the 7th minus 2, we would see that 7 minus 2 is going to give us 5. So that gives us a to the 5th. So I'm going to give you guys a question to do on your own here. And let's see how we do. So if I give you, let's go with a little bit more simple of a question. H to the 8th divided by h to the 3rd, right? I want you guys to solve this. Take a few minutes to solve this. You can work with a partner if you'd like. Turn to someone next to you. Now, I'm at about the 10-minute mark, so normally I would have a couple more examples that me personally would have gone over with the class, had them help me out with, and then I would have probably gave them a few questions to answer on their own, like I did with the multiplication. But because I'm under a time crunch and I hit the 10-minute mark, I'm just going to leave it at this, but I would go over this answer with them and give them a few more to work on. And then I would also give them a few more challenging problems from multiplication and division to just test their knowledge on the whole multiplying and dividing exponents.